Okay, hi guys. This video is about our geometry lesson 2.2.2, and it's all about area of something called a composite shape. And we're going to use this information to talk about triangles again today. We keep coming back to triangles in a lot of these videos because triangles end up being um, pretty important. There's a lot of special relationships built around triangles. So today we're talking about area. And this shape down below, if I asked you to give it a name, we wouldn't really have a name for it. We know typical shapes like triangles, we know rectangles and squares, and we've gone through our shape bucket and we've come up with other things like parallelograms, trapezoids, pentagons, but there's no real good name. We could call it a polygon, I guess, but there's not really a name for this thing. So we call this thing a composite figure. And composite means it's a shape that's built from familiar shapes. This thing's built by rectangles. I see a little rectangle on top, this one, and a big rectangle on the bottom. So I took two rectangles and I pushed it together and I made this one shape. So composite figures are shapes made from lots of familiar shapes like triangles and rectangles and things like that. And if you were asked to find the area for this thing, you'd have to go off your previous knowledge. Like, area of a rectangle is really easy for us. We know that every single rectangle has a length and a width that we can measure, has some dimensions, and we know that the area always equals the length times the width. And we've known that since probably since the 4th grade or something pretty young. So we're going to use this simple information that we know so well to find the area of a more complex shape. And you're going to do a lot of these in class in your book. There's tons of examples you're going to be working through. So I'm going to make up some numbers here. Let's say that there's a dimension of 3 units over here. And then this side is 8 units long. And let's say that this is 2 units and 10 units. And that's all I know about this shape. A couple of measurements. That's really all I need to know because I've already broke this up. I put my red line in here just to kind of help me. I know that this is a length of 3 right here, which means over here from this to this end must also be a length of 3. They got to match. If the whole thing is 8 and this is 3, then I guess this length must be 5. They have to combine to 8. If this length is 5, I suppose this length has also got to be 5. So if I want to find the area, it's not going to be too hard to do. I'm going to do length times width for this big rectangle, and then I'll do length times width for the little rectangle. So 5 times 10 is 50. So we're going to say we have 50 units squared inside this first big rectangle. And then in the little rectangle, 2 times 3 is 6, so we're going to have 6 units squared in the little rectangle. So if I wanted to know the area of the entire shape, I'd say the area equals the 50 plus the 6, so 56 units squared combined. And normally, anytime you're asked to find area of some odd-looking shape that doesn't really have a name, this is kind of our strategy. We break it up into little shapes that we are familiar with, and we already know how to find the area, and it makes it easier for us. So this brings us into kind of the next thing that we're going to do. We're going to be looking at triangles. And triangles have a unique thing because they can be built from squares. Watch this. Let's draw a square, a perfect square. And let's think about what we know about squares. For instance, we know they have 4 equal sides. 1, 2, 3, 4. So if I measured it and I said, like, I don't know, how about this is a side of 5 units long? Then I would know that all the other sides are 5, 5, 5. And if I needed the area, then I would say the area is length times width, 5 times 5, which is 25. So this whole square has an area of 25 units squared. Okay, no problem. This all review so far. But if I was to go through and say, okay, now take your rectangle and draw a diagonal line through the center here. And now we've split it into 2 triangles. You can see a triangle on bottom. I'll shade it in red. And then you can see this triangle across from it. If I asked you, well, what's the area of the red shaded triangle? Or even the area of the other side, they're matching. You'd say, well, the whole thing was 25. So I'd have to divide 25 in half to get one side of it. So the area of this thing would be 25 divided by 2. That's how I'd get the area, which if I divide that out is a decimal, 12.5. 12.5 units squared. So triangles are kind of interesting. You can get the area by thinking of them in terms of a square, doing length times width, but then dividing the whole thing by 2 so that you only get the one side of it. So we're going to write this down. Area of a triangle. Area of a triangle. It's like taking the length times the width of the square and then dividing it all by 2. In triangle language, instead of calling this length and width, we rename it. We say that this is the base and the height of the triangle. So we're doing base times height. It's the same as length times width, and then we divide it by 2 just to get the triangle. So we don't have the whole entire square. And this formula equals the area for any triangle. And really, you know, put a big bubble around this or a box or something, because this is something you want to just commit to memory. Base times height divided by 2. Base times height divided by 2. It always works for a triangle. And we get this whole concept from looking at it as a square and then dividing the square in half. That's basically what's going on. Now, it seems pretty straightforward and it should be usually pretty easy to do, but actually finding the base and finding the height can be a little bit tricky sometimes. So let me show you an example of what I mean by it being... Okay, so I'm going to make up a new triangle, and it's going to look like a... How about like this? I'm going to make an obtuse angle. And I want to find the area of this triangle. So what does the area equal? Question mark. We just learned that the formula for area is base times height divided by 2. So I'm going to be focusing on figuring out where's the base and where's the height. Any side of a triangle can be a base. Doesn't matter which side you pick. So you can use the bottom, you can use the side, you can use the other side, whatever you feel like. The bottom one that appears to be the bottom one in front of me here is this one. And I think that'll be a great choice for base. So I'm going to label it. Now here's the common mistake. Most people, a lot of kids will read this problem and see this long side and say, hey, there's the height. It's a really common mistake to say that this side length is the height, but that's not really true. Think about what height means. Height means how tall you are. When you stand up against a wall to measure how tall you are, you know, have you ever done this when you were a kid? Stood up, my mom did this all the time, stood up against the kitchen wall and she takes out the tape measure and she goes up and figures out how tall you are and marks it on the wall, and as you get older they keep marking it and you get taller and taller. Well, you never stand at an angle. Like, you don't get up to the wall so your mom can measure how tall you are and then stand slanted. That wouldn't make any sense. You stand up straight. This is not standing up straight. This is at an angle. So think of it kind of like that. If you want the height of a triangle, it's just like when you're standing up against a wall and trying to figure out how tall you are. You want to stand up straight. You want to stand at a 90-degree angle. So here's a straight line from the top of the triangle down. I extended the base so I can think of it like this. This is the floor, the ground, the base, and made a 90-degree angle. This, from here to here, is the height of the triangle. It's standing up straight. It's from the top of the triangle down to where the base is. So this is what you're really looking for, is this height number. And we would say the height is some value. So let's say the height is 8 units and the base is 6 units. Well, now I'm ready to tell you the area of this thing really quickly. Base times height. So I'm going to write area equals base times height divided by 2. And then I'm going to write underneath equals, area equals, and I'm going to multiply these. 6 times 8 divided by 2. Which is going to be really easy for me to figure out. 6 times 8 divided by 2 is going to be 24. 24 units and its area, so units squared. The area of this triangle is 24 units squared. So you have to be pretty careful about figuring out where this height is. Once you figure it out, it's usually pretty easy from there. Would have been completely different if I had decided to take this same triangle. Imagine I took this same triangle and had done this. I had flipped it upside down. Same problem. And I had said, oh no, I don't want that first line to be my base. I want from here to here to be my base. Now I've got this really big base number. It's going to be way bigger than the last base. But my height is so much shorter. The top of the triangle's up here, going straight down at a 90-degree angle. There's my height. It's a really little height now and a really long base. I'll still get the same answer when I do the math, but it just changes the problem. So you got to look at that triangle pretty carefully. So here I have something I want you to try. I want you to copy this triangle. So we're going to make up a triangle. And it's just kind of a randomly drawn triangle. And what I want to do is I want to look at it. I want to say that this big dark blue side is the base, B for base. Can you figure out the height? So pause the video and try this. Alright, so hopefully this is what you did. You turned it so you can look at it this direction and said, okay, the height goes up to the top of the triangle. Now it looks like we have a 90-degree angle, but I hadn't really confirmed that. If we have a 90-degree angle, then that's got to be my height. That makes sense. It goes straight up to the top. If I had a base like this, and then an angle like this, here's my base, the height is going to be going straight up to the top. Here's my height. So you see how that changes? Versus if I had a triangle like this, like we did earlier, and here's my base, now my height is over here. So all different scenarios, you have to look really, really carefully. So we're going to work on this in class. You're going to get in, you're going to do this lesson, you're going to look at composite figures, and really you're going to focus on triangles and base times height divided by 2 and work with that formula a little bit.